Problem 1, we have two logs with the same base on both sides, so we just set the arguments equal to each other. Subtract 2x from both sides, and divide both sides by 3. Okay, problem 2, again, logs on both sides, so set their arguments equal. Okay, set the logs equal. Set the arguments equal, I mean, because they're both logs. So P equals 7 divided by 9, or 7/9. Okay, here again we have two logs equal to each other, so we set their arguments equal. And then divide both sides by 2 to get k equals 2. 5, again, two logs equal to each other, set their arguments equal. All right, so problem 6. First, we should get rid of the coefficient, so divide both sides by 2. Next, to get rid of the log base 7, we can exponentiate and make both sides exponents of the base of 7. So 7 and log base 7 cancel out, leaving behind just the negative 2r. On the other side, 7 to the 0th power is 1. And then divide both sides by that coefficient to get r equals negative 1/2. Okay, so here I'm going to start by adding 10 to both sides. Okay, to get rid of the log base 3, I exponentiate. I make both sides exponents of a base of 3. So the 3 and the log base 3 cancel out, leaving just the n plus 3 behind. 3 to the 0th power is 1, and then subtract 3 from both sides to get n equals negative 2. Problem 8, I'm going to start by getting rid of the coefficient, dividing both sides by negative 2. Okay, to get rid of the log base 5, I exponentiate and set both sides as exponents of a base of 5. 5 and log base 5 cancel out, leaving the 7x. 5 to the negative first power is 1/5. And then divide both sides by 7. So 1/5 divided by 7 is 1/5 times 1/7, which is 1/35. Okay, so here I'll start by subtracting 2 from both sides. So now to get rid of this log, remember it's really log base 10. I'll exponentiate by setting both as exponents of the base of 10. So these cancel out, leaving the negative m behind. 10 to the 2nd power is 100. Then divide both sides by negative 1 to get m equals negative 100. Here, we'll get rid of the coefficient first, divide both sides by negative 6. To get rid of the log base 3, we can exponentiate, set both sides as exponents of 3. So over here, 3 and log base 3 cancel out. Over here, 3 to the 4th power is 81. And then add 3 to both sides to get x equals 84. Here we have two logs with the same base equal to each other, so we just set their arguments equal. Okay, so let's get all our terms on one side. So I'll add 12v plus 1 to both sides. Oh, sorry, that's not a v. Okay, so we can use the quadratic formula. We're completing the square. This one turns out to be factorable. So v plus 6 times v plus 6 equals 0. So the only solution is if v equals -6. Over here we have two logs with the same base equal, so their arguments must be equal to each other. So again, I want to get all my terms on one side, so let me add 11x minus 2 to both sides. Okay, this one is factorable. Okay, so x, if this blob is 0, x is -4. And if this blob is 0, x could be -7 instead. Okay, two logs with the same base equal to each other, set their arguments equal. Oops. Okay, let's get everything on one side. Okay, so this one is factorable. And then that means b could be +8 or -2. Okay, two natural logs equal, so their arguments are equal. Get everything on one side. Okay, we can factor this. So that means that n could be -2 or n could be -7. All right, so here we have two separate logarithms on the same side. So let's combine them into a single logarithm. When you add two logarithms, you multiply their arguments. Now to get rid of the log, which is really log base 10, I'm going to exponentiate, make both sides powers of 10. So these cancel out, leaving 8x equals 100. Divide both sides by 8. X equals 12.5, or 25/2. Here, again, we need to combine these into a single logarithm. So when you subtract logarithms, you divide their arguments. Then to get rid of the logarithm, I'm going to exponentiate and make both sides the exponent of 10. So since this is log base 10, 10 and 10 cancel out, meaning x/2 equals 10. Multiply both sides by 2. And we get x equals 100. No, we don't. 10 times 2 is 20. Okay, we want to combine these into a single single logarithm first. So when we add two logarithms, you multiply their arguments. Then to get rid of the log, which is really log base 10, we exponentiate both sides by 10. So 10 log base 10 cancel out, meaning 2x equals 10. Divide both sides by 2, x equals 5. Here we want to combine both logarithms on the left-hand side first. So when we add two logarithms, we can multiply their arguments. And now that we have two logs on both sides that are equal, we can just set their arguments equal to each other and then solve for our variable x. Okay, so we have two logarithms on the left side, so let's combine them into a single logarithm by multiplying their arguments. 2 times 4x squared is 8x squared. Okay, to get rid of the log base 8, we can exponentiate both sides by 8. Okay, so 8 and the 8 to the log 8 cancels out, so 8x squared equals 8 to the first power, which is just 8. Okay, divide both sides by 8. We get x squared equals 1. And then we square root both sides. So remember that x could be positive or negative 1. Okay, problem 20, let's combine the left-hand side. When we subtract two logarithms, we divide their arguments. Okay, now that we have logs on both sides that are equal, we set just their arguments equal. Okay, so I'm going to get rid of the denominator, multiply both sides by x. And then just subtract x from both sides. Okay, logarithms on both sides. Let's combine them into a single logarithm by dividing. Since the logarithms were being subtracted, we divide their arguments. Okay, so now we can set just the arguments equal to each other. Multiply both sides by x. Subtract x from both sides. So it's really 1x. So 29x minus 1x is now 28x. And then divide both sides by 28. Let's combine the left-hand side first. When we add logarithms, we multiply their arguments. Now that we have once we have logarithms equal, we set their arguments equal. Okay, so divide both sides by that coefficient. And then square root both sides. So remember, when we square root, we are having both positive and negative solutions. Okay, so we're subtracting, which means to combine them, we need to divide the arguments. Okay, to get rid of the natural log, we exponentiate. We make both sides exponents of e. Okay, so e and natural log cancel out. Okay, so let's get the x out of the denominator by multiplying both sides by that entire thing. Okay, so left side, these cancel out, leaving just the 2 behind. Right side, I'm going to go ahead and distribute this out. Okay, so I want to get the x by itself, so I'll subtract 2e from both sides. So I'll continue over here. So left side, 2 minus 2e. Right side is 3ex. And then divide both sides by 3e. Okay, so we want to combine these logarithms or natural logs. So here they're being subtracted, so we divide their arguments. Then to get rid of the natural log, we can exponentiate both sides, making them both powers of e. E and natural log cancel out. Okay, so to get the x by itself, let's start by multiplying both sides by 7. Next, add 1 to both sides. And finally, divide both sides by -3. Okay, so if you want, you can multiply top and bottom by a negative. So your answer would look like this instead. Okay, left side, we're subtracting 2 natural logs, so let's combine them by dividing their arguments. Now that we have natural logs on both sides, we set their arguments equal to each other. Okay, so let's get the x out of the denominator. We have to multiply by the whole thing though. And now subtract x from both sides and add 25 to both sides. Okay, so that gives us 4x equals 22. Divide both sides by 4, and we get x equals 11/2 once you reduce the fraction. 26, subtracting 2 natural logs, so we combine them by dividing their arguments. Okay, to get rid of the natural log, we exponentiate, put both sides as exponents of the base of e. So on the left side, e and natural log cancel out. Right side, we just leave as e to the 5th power. So now get rid of the denominator by multiplying both sides by 3. Subtract 1 from both sides. And finally divide both sides by 4.